So let's talk about how you actually do something with Python. We've talked about data types. We've talked a little bit about assignment, but we haven't really gone into it in too much depth. So assignment statements. We'll talk a little bit about how assignment works in more depth. We will talk about how equals actually works. We will talk about, somebody asked yesterday about how you undo assignment. We'll then go on to calculating things, expressions, comparisons, and then a little bit of comment on, a little bit of discussion of coding itself. Any questions before we get started? Okay. All right. So we saw some of this before. You take a value, you associate it with a variable using the equal sign. There's a tendency to think in terms of Fortran, where what this operation in Fortran does is it labels a memory location and it sticks some stuff into those memory locations. That's really not what happens in Python. What happens is that we make a data object and then we assign a label to help us reference it. So it's better to think of the equals operation as creating a label to access some object. And we'll see why that distinction matters. If you're used to thinking about languages that have pointers in them, what we're doing is we're creating a pointer to an object. One nice thing, or maybe not nice thing about Python is that you can combine an operator with an assignment, which is known as augmented assignment. So this statement here takes A and adds 1 to it. It won't work if A doesn't already exist. There are lots of other things you can do. You can do times equals, minus equals. You can even do logical operations. Okay. So far that sort of makes sense, except for maybe this oblique comment here, but you'll see why in a moment. But first, but you can do equals in more complicated ways. Here, I'm using equals to a tuple. Okay? More commonly, people will not bother putting in the parentheses, but here I've got a tuple, and here I have a tuple. They're the same length. So when I do this, it takes my tuple and it breaks it up. So A becomes 2, B becomes 4, and C becomes the third element, which in this case is a tuple, a nested tuple. Okay? More commonly, you'll see things like this done, where people just simply will put down A, B, and C equals something which has 3 values. So for example, it's not uncommon if you're calling a routine and you know the routine is going to return 3 things to just write it as if write it in this way. But the lengths have to match. If you have 4 things here or 4 things here, you know, if this case I've got 3 items on this cane, and it works fine with a list, by the way. Here I've got a tuple, here I've got a list. The operative thing is that the lengths match. Okay, so here I've got 3 items in my list, but I've got 4 variables. Error.
So is that middle one loading a list, loading a tuple from a list, but it has created a tuple because it's got.
It's what is it? That's a good question. It's I think it's doing. It's better to think of it as a mapping operation.
Yeah, but what I mean is that you have to define a tuple by the square bracket, right?
Well, I have to define.
Right doesn't have anything.
This is a tuple. This is a tuple. It's exactly the same as this. Okay.
So you created a tuple from the elements of a list.
I've broken it up because there is a tuple, but only C is a tuple. A is an int, B is an int, and C is A comma B comma C is a tuple. Yes, yes, this is a tuple. Yes. It's used. It's gone. Exactly. It may have been created instantaneously, although it probably wasn't. But you're not allowed to. Right. I could certainly now create, I could certainly, if I said D equals this, then I get a reference to a list. If I say D equals A comma B comma C, I've created a tuple and pointed to it by D. Okay. All right. And
Danger, Will Robinson, danger!
Okay. Equals does not work the way you think it works. Okay? And you can get yourself in real trouble if you don't remember that equals is just creating aliases. So let's look at the first example where you could get in trouble with equals. Okay? Here I've created a list. It's a fairly complicated list containing another list and a bunch of different data objects. And now I have copied that, one thinks, to B. But I didn't copy it. All I really did was say that B is a pointer. B is a label that points to this. Okay, because A is just simply pointing to this. And if we look at pulling out a little function, ID tells us where in memory these things are stored. If we look at the ID for A and the ID for B, they're exactly the same. They point to the same thing. Why does that matter? If I change A, B changes too. Why? Because A and B are the same thing. Okay. If I want A and B to be two different things, I have to force Python to do that. And this is where slicing becomes very handy. A slice creates a new object, creates a new copy. So when I do this, if I had done this instead of that, then I could change B and A independently because they would point to different locations in memory. But we're not done yet. Okay, it's not quite as simple as that, because what happens now? I should say point out, this doesn't happen when we work with simple data types, and it's not because Python treats them differently. But when we do, for example, this, so I've created a simple variable C. I've made D equal to C. Okay, so now C and D point to the same thing. And you might think that if I assign something to C, I'm going to change D. But I'm not. And the reason is I've created a new object, and I've made C point to that new object here. D is still pointing to the old object. Okay. Seeing some eyebrows go up. This is complicated. This is something that was probably the most confusing aspect of Python. So here we created the A and B point to the same object. And here, at this point right now, C and D point to the same object. But when I do this, I'm reusing C. And D hangs on to its old meaning. Now, where this really is most likely to bite you is in the following kind of a system. Okay, here I create a tuple and a list. A is a tuple, B is a list. C is a tuple created out of that tuple and list. Okay, so C contains two items, and the first item is A, second item is B. Okay, I can change B. Okay, and if I change B, C changes. Okay, so here I've changed the second element in B, so B is now 3, 99. And when I look at C, there it is, right there. Why? Because this tuple here is effectively contains two things. It contains a pointer to this, and it contains a pointer to that. So by changing this, I change it there. Okay, I can also address into C. So C sub 1 gives me the tuple. I'm sorry, gives me the list. Element 1 of that tuple started out as 4, became 99. If I set it to -1, okay, I've changed C. That makes sense. But also I've changed B. Okay. And you know what? That's a mistake there. Because that was supposed to be down here. So if I checked B right now, B should have been... Actually, I'm going to change that while I'm here. I don't know how I copied that wrong, but... So that should be 3, comma, -1. Okay. So B, I've now changed, I've addressed this element here, and now I've changed B. And then the really odd thing, but again, it's the way it works and it makes sense. Here I've created a new object, which is a string. I've changed B so that I've got the new object. C doesn't change. Why doesn't C change? Because C is still pointing to the old object. Okay, because my list all the time had referred to that and to that. My tuple had referred to this and to this. And I've just redeployed B as a pointer to a new object. Okay. If this were B sub 0 or B sub 1, I would be changing B in place. But here, what I'm doing is I'm replacing B. Okay. This is probably the most complicated and most easily the place where you can get most screwed up in Python with thinking of equals not as creating pointers but as actually addressing objects. So if this is so confusing, why does Python do it this way? Well, if you think about everything we've done so far, all these objects have been little things. There's no real cost in working with them. But when you start thinking of my Python object might be referring to a MAR345 image, you don't just want to create new copies of that without thinking specifically, yes, I really want to make 2 copies of it. But I can't tell you how many times I have found myself with code that doesn't quite work. As a matter of fact, I believe this is still the problem on 11BM with when you drag experiments runs around. I think that it's because of somewhere I'm changing something that's referenced somewhere else. Okay. All right. On assignment. Somebody asked about this yesterday. Yeah? Sure. This one? The one before? Mm-hmm. Yes, it would happen. I could put anything into C at this point. It would still be a new object. Yes.
If I were to do an ID on C and D after the second step, they'd be the same.
Right where?
Right, that's the second step.
Right here. They'd be the same.
All right, but once I did the C equals 3 and I did an ID.
They'd be different. It would have a new. Let's do it. Okay. So, all right. So let's see. So if we do C equals 3.14, D equals C, and we look at the ID of D, we look at the ID of C, they're the same thing. Now I say C equals 3. Actually, let's do, what did you want? A string? A list? Let's make it a list just for fun. Okay, the ID of D hasn't changed. The ID of C has changed because I created a new object. In this case, my object is a complex one. But if I do C equals 3, it's got yet a new ID. And D hasn't changed. Yes? If I do C equals D, then the ID goes back. Yes? Would DB go away? Wonderful question. It's on the slide, but let's try it. Okay, so let's delete D. Okay, we ask for the ID of D. Doesn't exist. Ask for the ID of C. It's still there. Okay. Yes. So 1 second. So the take-home message is that we are that what delete is doing is getting rid of the label. Didn't get rid of that object. The object in this case is my float. The delete. So you might ask, how do I actually get rid of the memory that was used by the object? And the answer is that that's something that Python does automatically. When it recognizes, what it does internally is it has a counter that keeps track of how many things refer to an object. And every time a label is created, that gets incremented. Every time the label gets decremented, every time the label gets removed, and there are many ways that can happen, the reference gets decremented. When it goes to 0, there's no way to use that object anymore because there's nothing that references it anymore. And when Python gets around to it and it needs the space, it cleans up. There's a question back there. Mm-hmm. Yep. Yeah, it depends on what it is that what kind of object it is. Okay. The simple way, if we're talking about things like lists and strings and so on, is to make a slice. So let's try. We'll say C equals test, and we'll say D equals C. And if we go back and look at our IDs, we'll see that they're the same. Okay. However, if I say it's a slice, okay, and we look at the ID, let's see, did that change? No. Maybe that doesn't work. Apparently that doesn't work for strings. Yeah, it must be because it's immutable. Let's see. Yeah, I guess that's because you can't change this. You can't change it. Let's do that with a list. That'll be a better example. So we'll say C equals ID of C is that. If we say D equals C, ID of D should be the same, and it is. But if we make a slice and ask for its ID, then we see that we've made a copy of the list. So you're absolutely right. The difference with the string is you can't change a string in place. Once you've created a string, it is what it is. So it doesn't need to make a copy when we ask for the whole thing. We would make a copy of that if we ask for something shorter. So if I say C equals test and then D equals 0 to 2, so that's the first two letters, and the ID of D should not be the same as the ID of C. Yes?
So a common coding requirement is to grab a value
Mm-hmm. Mm-hmm. Right. Correct. It depends whether it's mutable or immutable. If it's a string, if it's a float or an int or something like that, then that's fine. But if you want to say, is old list the same as new list, then you better make a copy of it. Yep. Right, because when you do c equals c plus 1, then I've made a new c. Correctly, that's correct. C is now pointing to a different location in memory. Not that you care, but c plus equals, no, that's it's still not going to be. So if we do c equals 1, and we look at the ID of c, and we do c plus equals 1, new location. Yep. 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 No, because I never, because there would be if I'd made a point, made another variable, but now it's too late. It's gone. Yes. Yes. There's actually, I mean, this is pretty. What you're asking about is how do you go copy objects, and it turns out, right, it turns out there's two different ways of doing copies. There are copies and deep copies. Okay, and it has to do with how many levels you go down. Okay, in a regular copy operation, you make a new object, but if there are pointers inside that object, you don't duplicate those. But a deep copy goes through and copies everything. It depends whether you call copy or deep copy. Yes. I have no idea. I have no idea, to be honest. I have never tried to do anything like that. Right. That's exactly the same question as before. Is there a way that you can take a location in memory and okay. Right. I really don't have any idea on that one. I really don't know. I'm sure you could, I know for a fact you could write it yourself. Okay. What you can do is, I mean, this is way, way beyond it, but it turns out, excuse me, that everything in your Python workspace is in a dictionary. So you could go through all the dictionaries and check the IDs of all the items. But you'd have to go through multiple dictionaries because conceivably you could be pointing to the item at both, your local level and then there's a global level and things like that. So it's not trivial, but it's in theory possible. I have to say that I've never needed to do either of those things, but maybe that would help me with the bug that I have on 11 p.m. Okay. All right. So I see I've suitably impressed you with the importance of this one confusing aspect of Python. All right, and we talked a little bit about deleting already. That here I've created a variable, then I've deleted it. Here I created a variable, and I deleted a little bit later, but I've saved a pointer to it. In this case, the delete doesn't do a whole lot. Okay, it didn't get rid of this object. All it did was to get rid of the pointer to it. This doesn't matter under normal circumstances, but when you're working with that, if A was a gigabyte and I want to get my gigabyte back, in this case, I'm not going to get it back. All right, so expressions. Expressions happen when we use operators. So here's a very simple expression. I've taken the integer object 2 and I've added another integer object 2 and I've put it into B, or I've created a pointer to that new object and which is A. I can do the same thing with variables. I can stick expressions into other types of object creation. So here I've created a dictionary and I've defined 2 as 2 to the 10th. And I've done the same sort of thing, except I've used the power function, which does exactly the same thing. And I've said 3 is 3 to the 10th. Here's a weird one, 3 times spam. Okay. So if we, what's that? Lunch, yeah. Well, you guys may have had lunch, but I haven't. So if we look at these things, okay, when I run this one, 2 is 10 to the 2, and 3 is 10 to the 3. 3 to the 10th, excuse me. 2 to the 10th, 3 to the 10th. Yes, thank you. And 3 times spam, in this case I've stuck a space in the end, gives me spam, spam, spam. That's just the way that integer times string has been defined for us. I don't believe floats are defined that way, and I'm not going to test. You can leave that. I'll leave that one as optional homework. Okay. There are lots more expressions. I'm not going to try to give you a list of them here. But if you go, but here's, if you want to see a list, this Software Carpentry website has a list of all the things you might want. Okay, comparisons. Comparisons are a specific type of expression that evaluate to either true or false. And the first thing I just want to remind you that true is true only if it's capitalized. Okay. So if we say, is 2 greater than or equal to 4, that test evaluates as false. Is 2 less than or equal to 4, that evaluates as true. What kinds of operators can you use? Well, you can use the ones you'd sort of expect. Equal, greater than or less than, greater than or less than, and equals. The equals always comes after, by the way. If you want to test, are two things the same, use equals equals. Why not just a singles equal sign? Well, you use equal signs for assignments. You use 2 equal signs for comparisons, and Python won't let you mix them up, in the sense that if you try to do a comparison and you only use 1 equal sign, it's going to say assignment is invalid here. There are some special kinds of tests. In, not in, is not. I'm not going to worry about what is and is not is right now. That tests for object classes. So it used to be if you wanted to test if something was none, you didn't say, you wouldn't say A equals none. That now works. You would say A is none. But we really don't need that right now. But in and not in are really useful. Okay? So rather than having to write a loop to find out is 2 in my list, I can just type 2 in 2, 3, 4, and it comes back with true. Okay? 2 in This list is false because 2 is not an element in that list. Okay? If I said 2 in referencing this element 0, that would have been true. Okay? But I can ask, is the tuple 2, 3 in this list? And the answer is true. Okay? And this one is sort of weird. You might ask, if you leave out the parentheses here, you come back with this rather strange operation. And I think I've done this with a... Yeah, there we go. Why? The last one's really strange. Okay? But it comes down to the parentheses. This, starting with the comma, is my expression. So I could, to write it out, I've got that expression right there is 3 in this, and the answer to this is false. So I substitute a false in right there, and I get 2 comma false, and that's what my answer is. Yes?
On the first one, if you used a variable, obviously, it worked with n.
Mm-hmm.
What's a crazy thing called underscore underscore contains underscore underscore? Is that basically the same function?
I think that in maps to that. But that's so, and that really comes back to if you're creating your own class. Okay. Yeah. That's really way beyond where we are right now. So, okay. All right. But I wanted you to see that this expression here, because it looks like it's straightforward, but because you haven't specified parentheses here, this is one object right there, which happens to turn out to be false. We can combine comparison. We can combine comparisons by using and, not, and or. So here I've said one comparison. C is just going to be just going to be tested by itself, and here's a third comparison. Okay, and I recommend whenever you do a multiple, you use multiple comparisons, use parentheses, because you might think that when you wrote this down that you want this, but you're not going to get it. It's going to evaluate this expression, then it's going to end it with that, and then it will OR it with this. Okay, so they'll work out differently depending on what these things are. All right. Coming to the end of this module, what if you want to put comments in? This symbol here we'll either call the hash or the pound sign. And anything after this is a comment. So I can write a program. We haven't talked about the if statement yet, but this got nothing. This effectively has nothing on it that the interpreter is interested in. In this case, the interpreter only stops scanning when it gets to that pound sign. Okay, that's not true if I put it inside a string. But again, this is a comment right here. Okay. Now here's something a little weird to Python. What happens if I just put a string into my routine and I don't make a reference to it? I don't assign it to anything. Well, I've created a string and I've immediately deleted it because nothing refers to it. Well, for whatever reason, Python will actually use these kinds of strings, and when we talk about this, when we talk about writing functions, we will use strings that are not equated to anything as a way of sticking comments in that are specifically recognized. So a character string that's not assigned to a variable in Pythonese is just called a doc string, documentation string.
Why would you do that? So you can comment.
why you do that? Well, it turns out that there are some this will turn out to be picked up by help, and this wouldn't. Okay. There are style guides that, if you want to get into that, but we'll talk much later about about how to write routines in such a way that they're documented. As a matter of fact, I think we're going to get a Python interest group talk about Sphinx at some point. Yeah, Debbie's going to talk about Sphinx, where you can do really sophisticated things with these doc strings and get out really fancy documentation. Okay, what if what you want to do doesn't fit on a line? Well, it turns out that that's something that happens all the time. And there is a way that you can use a backslash to indicate this is the end of a line and just continue what you want. But the easiest way, excuse me, almost always, is to use is to stick in some parentheses or any other symbol that opens a list definition. So I want to define a tuple here. I say a equals and then a parenthesis, and then I can put as many lines as I want after that point, and the interpreter recognizes you haven't closed the parentheses, so therefore everything is still part of this line. Likewise here with a list, and here with a dictionary. Okay, and you can almost always take care of any kind of continuation like this, and it's much more easier to read than when you start trying to continue lines with backslashes. The only reason I even mention the idea that you continue lines with backslashes is you might see it in somebody else's code. But I will say that to date I have never had to use a backslash to continue a line. Yes, 2 questions. Absolutely. Put it in parentheses. Okay. If you have, I can't say a equals 2 plus and then continue it like that, but I can say, oops, that should have been equals anyway. A equals 2 plus 3. Now it's waiting for more input. 4 plus 6 plus, and it's still waiting for more input until it gets the final parenthesis. Okay, and I could have even done that with just simply parenthesis 2 plus 2 plus 2. Okay, yeah. You got a question? If you want to do the same thing with a string, there are a couple ways. First of all, we talked yesterday about the idea that you can use 3 quotes, and then we can okay. So that puts new lines in it. Another way would be to do things is sort of interesting. A equals parenthesis test. I'm going to need quotes. Sorry. Okay. Okay. So what's happened here is I showed you yesterday that if you just have one string right after another, okay, then they just get concatenated. And I used different quotes here just to show you that I could. Okay, so that's completely the same as doing A equals test, and so on. Okay, so you can so those parentheses all do, you know, the parentheses are basically ignored. They're just doing grouping. Yes, another question. Yes, I know exactly what you're saying. A equals. That doesn't work because with the single quotes, it expects that to end at the end of the line. It would have been fine with the triple quotes. Okay. You'd need a parenthesis to end it. Okay. All right, I think that's it for this. Okay, homework. Oh, question first. Yeah, sure. Inside the tuple, right, all these things are, all the spaces here are ignored. The only way that wouldn't be true is if there were quotes. Then the spaces are part of the quoted string. You know, if I had a quote right there and a quote right there, you know, or something like that, then, you know, my spaces might matter. But Python doesn't care about white space. It doesn't care about the white space of the carriage return here. It doesn't care about any amount of white space except before the beginning of the line. We'll talk about that. Okay. All right. So I got some homework for you. Okay.